Hello students. My idea was to keep those lecture notes timeless, but I don't know if that will be if that is possible always. Excuse for the fact that the first lecture or the question section was not going well. My laptops did not start very well and I got problems. But later on it went well, and please have some patience. If after a start of such a session, if you have 10 minutes or a quarter you cannot do something, then maybe it will not go, it will not start or something like that, but most of the time it will always be start. So be patient. What to do now? I have in mind to, or I have in mind, I see in my lecture, in the, not in the lecture notes, but the study guide, P5, P6, P7 and chapter 1.2 of section 1.2 that I have in mind. How far I come I don't know with my those videos. Every video is about 1/2 an hour, and together they will be something most of the time 2 hours or something like that, and not more than that. Okay, this is week. I don't know how I have done it with my other lecture notes, so I have to look, and I see lecture that I have. So this is lecture 2, and then the first part of it. So lecture 2 and then part A, and we are, this is 2DL 00. Okay, let's start with that P5 out of Adams. What is told to you there? Now there is told to you how to combine functions, and then I mean with combine, adding, multiplying, and then some other things. So if you have two functions, and those functions, they have some domain and they have some range, and I assume that f and g have the same domain. Otherwise I cannot do what I will tell to you. Now what can you do? You can add those functions together, and then what is meant by that? Now if you add those functions and you let it work on x, you can calculate it by the function value of x plus the function value of g. So this is addition of two functions. Then you have also a multiplication of functions, and be careful with that. So I mean the function f multiplied by g, and what is meant by this here is meant fx times the value of gx, and be very careful. There is another, you can also do some other combination, but then you have not a point. Here staying some point and just some multiplication and nothing else than that. Multiplication. And what do we have more? Yes, this one here, and we can also divide two functions together, and if you divide them, you have, it is defined by the value fx divided by the value of gx, and then there is assumed that the g of x will not be equal to 0, otherwise I cannot do this this division of those two numbers. And then you have, yeah, I see that I have only done the addition, but you can also subtract functions. And if you subtract them, you have the function of fx minus the function of gx. Why I do this, the last one? Now, in certain sense, I can here also write f plus, and then I have minus g. So I have and then I can use that rule of the addition. Yes. And what can I then do? Then I see here some minus 1 and minus g I can of x I can also read as minus 1 times g of x, and then this is the function f, which is some constant, which gives you always minus 1, so the f of x is minus 1 for all x. And then I use that rule of the multiplication, and I get minus 1 times the value of g. And I see that I come to this here. So in certain sense, I don't have to write down f minus g. I have not to define that, because I can make it out of the multiplication of functions and out of the addition of functions. So therefore I think those things are the important ones. And then be careful with something, and that is with the following. If there is staying the f of x and then here some minus 1, there is meant a 1 divided by the value of fx. So this is of importance. So you see here some minus 1, you have some brackets around the function value, and that means 1 divided by the function value. But you have also something else, and that we shall later see in chapter 3 or something like that. You have also this function here with some minus 1. So you have the function f and then here some minus 1. With this is meant the inverse function. So the inverse function of f, and that is completely, that is something else than what I've just defined by that minus 1, so that you have the 1 divided by the f of x. What is yes, let I see some example of an inverse function. And that inverse function, that is not 1 divided by fx. Be careful. For instance, what can we do? So some example of an inverse function. We have, for instance, the function f, which is equal to x squared, and let me take the x greater than 0. Then can I make some graph? I have the horizontal, the x-axis here, I have the 0, and here I have the y-axis. And if I make some graph, that function goes walks away along the x-axis and goes then up. And then here I have some graph, y is x squared. Now I can mirror that function in certain sense in the y is x line, and if you mirror it, it walks away steep along the y-axis, and then it goes that way. And that function here, yeah, what will that function be? Now that function will be the square root of x, or that is the square root of x. So we can what do we have? The square root of x squared is equal to the absolute value of x always. So is that square root of x squared defined, and because of the fact that the x is positive in our case, this becomes equal to x if the x is positive. And what can we now do? We can define the inverse function of f by the square root of x. And then we have the following, that if we have the inverse function, if we let it work on f, if we combine those functions, so I'm not multiplying but I'm combining these functions, then I have here staying the f of x is equal to x squared. I have to take the square root of it, and because that gives you the absolute value of x, and because of the fact that your x is positive, you get x out of it. And even so, you can do the other way, in this case, that you take the square root of x, then you let the function work on it, and you get the square root of x squared, and that gives you the x. And so I see that I have something that I have, that if I combine those functions, so if I fill in your f and you get x out of it, then you have the inverse function. Then is the f with that minus 1 the inverse of f. And even so, f inverse working on f. So if those things are the case, then you have the inverse function. In chapter 3 we will come back to it. But I hope that you see that the inverse function in that example, that was the square root of x, and if I have the f of x and that I take to the power minus 1, I get 1 divided by x squared, and those functions are not the same. So be very careful by reading those things, and don't read it on the wrong way. Very important. And so f inverse is not equal to 1 divided by f. Yes, and I let stay, but I take it away because most of the time this gives a lot of trouble. But be careful. Okay. Now, yes, what to do more? Oh yeah, and I have now combined functions. And because I have filled in other functions to each other, and what does it mean? If you combine functions, you have the following. You have no multiplication but some circle, open circle, f working on g, and that means that you first calculate the value of g and then you calculate the value of f of g of x. So here you have a combination of functions. And also this is not the same as multiplication. So if you have a combination of this one here, that is not equal to f times g of the first one. You calculate first g and then you calculate the function f of it, and of the other one you multiply those values fx and gx together, and most of the time they will not be equal. And I write here not equal, and I have to say most of the time. There are maybe functions where it goes well, but most of the time they are not equal. So I have some, for instance, if you have the following, if the f of x gives you 1 for all x, and if your function g gives you 1 for all x, then if you combine those functions, if you let work them on each other, you get 1, and that is equal to the multiplication of those functions that will also give you 1. So, but that is just some, but that is not always true. And for instance, let I see that it to you that it goes wrong. Now, if we let the g of x, if we let it equal to the square root of x, let the f of x be equal x squared, and then you see if you combine them, you have, so you let f work on g. Now then you have first the g of x, that is the square root of x, and then you have to take you have to take them in a quadratic term, and that gives you x. And if you multiply those functions together, you have x squared times 1 divided by the square root of x, and that gives you x to the power 3 over 2. And you see that they are not equal. So I hope that you see the difference between multiplication and the combination of functions. Be careful. Now I look in Adams and then I see some some functions defined, for instance, the sine of a value. Now that is, yeah, you can say x divided by the absolute value of x if x is not equal to 0, and that is maybe a nice definition of the sine of x, an easy, but then there's only one problem, what to define. If x is 0 and x is 0, then in certain sense it is undefined. But sometimes they also say that the sine of 0 is 0, but in Adams they say x is 0 undefined. Now what do you see if your x is positive? Now if your x is positive, then you have x divided by x, and that gives you 1. And if your x is negative, then the absolute value becomes minus x, and if you divide those values you get minus 1. This is the case for x is negative. Now that you see in Adams. I think that this is an easy way by defining the sine function. And so I say sometimes the sine of 0 is 0. You have to read the books to see what they do there. But the problem is that if you make some sketch of that function, you have on the left side you have minus 1, and on the right side, if your x is positive, you have plus 1, and then it is the question from what to do if you are around 0. If you walk around 0, you see you are jumping from minus 1 to plus 1, and then you can ask yourself, yeah, what to do there. Okay, now this is in certain sense chapter P5. Look to it once more. And oh yeah, and also piecewise defined functions. Now, for instance, you can have and piecewise there is meant that the real axis is cut up you have partitions of your real axis where the function is defined separately with some completely other formulas. For instance, that example in Adams, you see x plus 1 squared. If the x is less or equal minus 1, it becomes minus x. If your x is greater than minus 1, or there is staying this one and less or equal to 1, and you have x minus 1, the square root of it, if your x is greater or equal to 1. Now here you see your function is piecewise defined, so you have a partition of your real axis, and on those parts the functions are different defined. But be careful with that less or equal terms. If you do some function, because I think that I have made some fault here. Here there has to stay less than 1. Be careful that at those points where the partitions are made, that the function values are equal. And so therefore I think that I have also to make I don't know if there is staying here, I made some fault. Here is staying x is less than -1. At those points maybe the function's values are not equal from the different partitions, and then maybe you are jumping from one function value to another value of the other real value. So you have here the y-axis 0, we have the interval -1 +1, and then we can make some graph of it. There is there is staying there. The y is minus x between -1 and less than 1. Now, so we can make an easy graph that is just a straight line, and if you are in -1, you get the function 1, and if you are in +1, you are not getting, but you are going to the function 1, -1, but it is not equal to 1, not equal to -1. So therefore I have an open. Now and then you go to some other, the square root of x minus 1, for if x is positive, x is greater than 1. Now what do you see? If x is equal to 1, you get 0 out of it, and then you have, that is also the real value, and the square root is always going straight up and then going here. So here you have y is minus x, here you have y is the square root of x minus 1, that is the part, and the other one is some quadratic function, and I see that you have 0 if you fill in -1, but that will not be the value of that function there. The function of the value is equal to 1, and then it goes up. And so you have here y is x minus 1 squared. It is positive, and it starts, if you fill in, sorry, do I do it well? Yeah, +1. If I fill in -1, I get 0, and so, and here you have some function which is piecewise defined on different parts of the real axis. You have a different function, another definition of your function, and be careful if those numbers here, that they are not, if they are equal, no problem, but here you see they are not equal, so you have to be careful by making a graph. And now we go to the polynomials.